Part 4 of lecture 3, sorry. This topic is about the barometer. Barometer is a device for measuring atmospheric pressure relative to the vacuum. And so we use air suction until the P naught is equal to 0. This measure value called the absolute atmospheric pressure. Okay. And in this case, we use mercury for the mercury barometer to the fluid. We choose the mercury for the fluid, put in a glass tube, okay, length about 1 meter in the Hg bowl. And in this case, the different pressure between PA and P2 is equal to gamma m and 0. Different subtract h, so it means the h is equal to PA divided by gamma m. In this case, gamma m is gamma of the mercury, so it's from the density of mercury, 15,000 times the G. So we got the gamma of H is about 133,000 Newton per cubic meter. And we can estimate the height of the Hg in the tube is equal to 0.67 meter. Okay, that is we can measure the atmospheric pressure using the mercury barometer is about 0.660 meter. Okay. In general, for the absolute pressure, for the atmospheric pressure, so we can say that that is the standard atmospheric pressure is for the Newton per square meter is 1,000 Newton per square meter, or equal to 14.7 Pascal, or equal to 760 millimeter Hg, or about 29.92 inch Hg, and about 10.33 meter of water, and 1.1325 bar. That is all unit of the atmospheric pressure in terms of the absolute pressure. P1, the different pressure between layer is depend on it depend on the elevation. Pressure is different between layer. We can use the tube filled with the static fluid to measure the pressure between 2 points. We call manometer. There are many types of the fluid used different density in the equation. So in this case, we use different layer of the fluid, for example, oil, water, glycerin, mercury. Okay, and we can estimate the different pressure between 2 points, 0.1 and 0.2. Okay, so different pressure between 0.1 and 0.2 is equal to rho g times the different elevation between 0.1 and 0.2. Okay, between 0.3 and 0.2 the same, and 0.4 and 0.3 the same. The different one is the density of the fluid. Okay, and we can find the different pressure from P1 and P5 at the bottom is equal to summation of the gamma H, and we can estimate the P5, okay, the pressure at the bottom using this equation. And this shows how to find the connection between pressure from different points. The concept is the lower elevation, higher pressure, or higher elevation is lower pressure. Okay. In this case, we start from PA, this point at the PA, and we move to the first point. Okay, so this is at this point, at point 1, P is increased because it's lower elevation. So at this point 1, P is equal to PA plus gamma H1, and difference Z between ZA and Z1. and this curve is jump across. It means pressure at point 1 and point, let's say point 1 plumb. Okay, point 1 and point 1 plumb, the pressure is equal. We can use the concept of jump across. It's possible because of any point, 2 points at the same elevation in the continuous mass of the same type of fluid will be at the same pressure. Okay, so we can say that pressure at point 1 plumb is equal. And we move to point 2. The pressure decrease because it's moving up. So that is we got the pressure at the point 2. Subtract the gamma 2, Z1 and Z2, different Z1 and Z2, and equal to P atmosphere, because at this point is open, is a PATM. Okay, so we can use the concept that the P down is equal to P up plus the gamma, the delta Z. Okay.